Today, in this video, we are going to go over atomic structure in a very simplistic and basic way. Atomic structure is the structure of an atom. There is one positively charged nucleus with negatively charged electrons. Niels Bohr proposed an atomic model similar to the solar system where electrons are found revolving around the nucleus. Electrons are found in specific energy levels where they can move from one energy level to another by absorbing and releasing energy. These are the structure of atomic model and analogy.
What is an atom? Atom is the smallest particle unit of the matter that possesses the properties of the chemical element. Elements are the substance that compose of just a single atom. Structure of atom. Atom consists of a central nucleus that contains protons and neutrons. Protons are positively charged and neutrons have no charge, and this makes the nucleus overall positively charged. Much like how the sun has planets orbiting it, the nucleus has electrons orbiting. Electrons have a negative charge. Isotope. Atoms of the same element with a different mass number are known as isotopes. They are defined as atoms of an element which have the same number of protons, but a different number of neutrons. If we look at carbon and nitrogen, are they isotopes? They have different mass number, but they also have different numbers of protons. Therefore, they are not isotopes. They are completely different elements.
Atomic spectra. Atomic spectra defined as a spectrum of the electromagnetic radiation emitted or absorbed by an electron during transitions between different energy levels within an atom. Definition-wise, continuous spectrum having all the wavelengths within a given limit, while line spectrum only having some lines of wavelengths. Continuous spectrum contains all the wavelengths in the range, while line spectrum only with a few wavelengths. Continuous spectrum generates when both absorption and emission spectra of one species are put together, while line spectrum generates in either absorption or emission. So, there are the continuous, emission and absorption spectra. And now, it's on the quantum mechanics model. In other words, it's going to be our current model of what an atom looks like. The quantum mechanics model describes the energy level of the electron in three-dimensional space or orbital. Four numbers called quantum numbers were introduced to describe the characteristics of electrons and their orbitals, such as principal quantum number, azimuthal quantum number, magnetic quantum number, and electron spin quantum number. Electron orbitals. The magnetic number can range from -1 to +1. The number of possible values is the number of lobes or orbitals there are in the s, p, d, and f subshell. The s subshell has one lobe and can hold up only 2 electrons. P subshell has 3 lobes so that it can hold up 6 electrons. D subshell has 5 lobes which can hold 2 electrons each, so total of 10 electrons. F subshell has 7 lobes that can hold 14 electrons. This can be seen in this figure.
Electron configuration. The electron configuration is the distribution of electrons of an atom or molecule or other physical structure in atomic or molecular orbital. There are two ways to determine how the electrons are arranged in an atom. First, from the periodic table, and second, by looking at the diagonal rule. Electronic configuration of atom. The electronic configuration also shows how the electrons are distributed or filled and the arrangement of electrons in atom. We can actually write the electronic configuration by using two ways. One is the SPDF notation and another one is orbital diagram. For example, when we look at the nitrogen atom on the periodic table, the SPDF notation is going to be 1s2, 2s2, to P3 and the orbital diagram as below.
So now, let's look at sulfur. There are the SPDF notation and orbital diagram. Sulfur has 4 electrons in the 3p orbitals. The 4th electron in this orbital will be the first one to pair up with another electron, therefore giving it a negative half spin anticlockwise. That's all for today. Thank you for watching and don't forget to like, share and subscribe. See you next time.